Hello everyone, this is Sumita Gupta. Welcome you all for my next tutorial of electron devices circuits. Today we will solve the numericals on low frequency analysis. Today we will solve 4 numericals, and these all 4 numericals are very important, and your all doubts will be clear regarding low frequency analysis. And from Mumbai University point of view, these are important questions because these questions were asked in the previous year examination. So first of all, the question is, for the given amplifier, we have to determine the lower cutoff frequency and midband voltage gain. And the given parameters, input voltage BB is 0.7 volt, V is infinite, beta, that is current gain is 200. So remember, they are asking for lower cutoff frequency. So just have a quick look of the frequency response. There are 3 frequency range: low frequency range, mid frequency range, high frequency range. If we are doing mid-frequency analysis, then all the capacitors will behave like a short circuit, whether it's a coupling capacitance, bypass capacitance, discrete capacitance, internal capacitance. But for low frequency, coupling and bypass capacitance will behave like a short circuit, will not behave like a short circuit. These will be connected. And for high frequency analysis, transistors internal capacitance will be connected. We can't ignore that. Okay, so since in this question it is asked lower cutoff frequency, means this part will comes in row picture. Means we have to connect the coupling capacitors for the analysis. Okay, for midband voltage gain, means they are talking about this part, so all the capacitors will be short circuit for the analysis. Okay, so we have to do 2 types of analysis: one for low frequency analysis for lower cutoff frequency, one for mid frequency analysis for the midband voltage gain. Okay, given parameters, V is infinity, means R naught will not connected in the circuit. Okay, so first of all, you should always understand what is asking in the question. It means what parameter we want to measure. So now it is clear in the picture in the mind that we have to calculate the cutoff frequency and we have to calculate the mid band gain. Okay, so this is the given circuit diagram. Okay. So this is the given question. Okay. Now in this question, only one coupling capacitance is given. There is no output coupling capacitance, no bypass capacitance, only input coupling capacitance there. So our analysis will be very easy. We have to do analysis for only coupling capacitance CC1, not for CC2, not for bypass capacitance. Okay. So whenever we are doing any analysis, we are doing solving any numerical, you should remember 3 steps. First step, we have to do DC analysis. Okay. Second step, we have to find out all the transistors parameter GM, R pi, R naught, and the third step is your AC analysis, or we can say small signal analysis. Okay. So always remember, your first step will always be DC analysis. And from DC analysis, we generally find the Q point. Okay, Q point means IC and VC. Okay, so it can be asked in the question, find Q point. Otherwise, indirectly you have to find the Q point because that is a requirement of the transistors parameter. So we'll start the numerical. So step 1 is you have to do DC analysis. Okay, remember one thing: for any DC analysis, your capacitance will be open circuit. So this will be open circuit. If it is open circuit, this part is removed from here. So only this part is there. Suppose I am giving its name R1, this is R2. Okay. So this is your R1, this is your R2, this is your RC, and this is your RE. Only this part is remaining. Now we can redraw the circuit. This R1 can be connected here. See here. This R1 is connected to VCC and R2 is connected to ground. So this circuit can be redrawn here. R1 is connected to VCC and base, and R2 connected to ground. Okay. Now the next part is same. This is called voltage divider equivalent circuit. Now, if you remember, you have learned the Thevenin equivalent circuit. If you want to draw the Thevenin equivalent circuit, what will the parameter? We have to calculate Thevenin equivalent voltage or R equivalent. So what will the R equivalent? R equivalent will be R1 parallel R2. R1 parallel R2. What is the Thevenin equivalent voltage means? Voltage across R2. So if you will remember the voltage divider rule, so as per voltage divider rule, voltage across R2 will be calculated as R2 divided by R1 plus R2 multiplied by BCC multiplied by BCC means the branch in which you are going to calculate the voltage, that resistance will be in numerator divided by total resistance multiplied by given voltage. Again, listen carefully. We want to calculate the voltage across R2. The voltage across R2 is R2 divided by R1 plus R2 into VCC. So in this, we will calculate voltage V and R. R is R1 plus R2. So just put the value 20 and 2.2. Solve the calculation and check whether you are getting the same answer or not. So pause the video for the second and just do your calculation and match. Maybe there can be some manual mistakes. Okay, so now we can redraw again this circuit, that is in Thevenin equivalent circuit. So both Thevenin voltage was 1V. After calculation, we have found out 1 volt and RV is 1.9. So this is your actual circuit. Okay, so remember, what is the first step? DC analysis. For DC analysis, this is your equivalent circuit. And DC analysis means you have to find out IC. And if it is asking for Q point, then you have to find out IC and BC. If it is not asking about Q point, then you have to calculate only IC. There is no need to calculate BC in that case. Okay. So remember two things. If Q point is asking in the question, then you have to find out both parameters. But for transistor parameter, we need only current. Okay. Now, how to find out current? If you have done my previous lectures, then you know. First, we have to apply KVL equation the left side. Then, you know, IC equals to beta IV. So, when we apply KVL equation the left side, what is the equation? V minus current across is IV. So, V minus IV RV minus plus to minus means minus BBE. Then plus to minus means with minus sign minus IE RE equals to 0. Okay, and we know very well IE equals to IB plus IC, that we can write 1 plus beta because IC equals to beta IB, so we can write I equals to 1 plus beta IB. So just if you put this in this equation and you will rearrange, that expression for IB will be V minus BB upon RB plus 1 plus beta RE. So when you will do multiple question, when you will solve multiple question, then you will you can learn V minus BB means that the gap of voltage divided by total resistance RB. And just remember one thing. If this is a direct trick, you don't need to apply any KVL. Just difference is voltage divided by total resistance. The difference voltage B minus BB, that is numerator, divided by resistance RB plus RE. But here the current is flowing IE and here current is IB. So we need same current. So if we put the same current, then what is IE? IE equals to 1 plus beta into IB. Okay, IE is 1 plus beta IB. So now what you can assume, the current is IB, then resistance will be RE into 1 plus beta. So simple trick is, now you understand my points. Again listen carefully. This is RB and current is IB. So here RE current is IB. So I am not writing IE. I am writing 1 plus beta IB. 1 plus beta IB. So just take the current as a IB. So what are the resistance? RE into 1 plus beta. Now you want to calculate IB here. So IB will be difference is the voltage. The voltage is V minus BB divided by total resistance. The resistance is here resistance RB and here we will take resistance 1 plus beta I. 1 plus beta RE. That is a short trick if you want to learn it. Means there is no need to solve this KVL. Just remember that if you are actually you are taking KVL, so current should be same. So here is current IB to here current should be IB. So IE will be 1 plus beta IB. That is okay. So now we have calculated the value of current IB. If IB is there, then you know very well what is IC. IC equals to beta into IB, and beta is given in the question. What is given beta? Beta is given here 200. So just multiply by 200. Okay. Then you will have this value. Okay. I have directly pasted here, so please verify your with your calculation whether this is correct or not. Okay, if there is any changes, then you can type in chat box. Okay, so that was the first step. Remember what we have done in the first step. Generally, the circuit is of voltage divider network. So just what you have to do, you have to redraw the circuit in terms of voltage divider equivalent circuit, or we can say Thevenin equivalent circuit. Okay, so this is the main circuit. Whatever the circuit is given, you have to convert that circuit in this part. Because in this circuit, it is easy to take the KVL equation or to find the IB. Then we have calculated IB and IC equals to beta IB. So that is step 1 only. Step 2, transistor parameter. And the transistor parameters are transconductance, input resistance, output resistance. So input resistance value is BT. BT is a thermal voltage that is fixed, 26 milli. This is wrong, millivolt. Okay, 26 millivolt. So BT is thermal voltage. If you remember, it is KT by Q. K is your Boltzmann constant. T is your temperature, room temperature. Q is a charge of electron. When you will put all these values, then you will have 26 millivolts. So it may be or may not be given in the question. You should remember it. And IB you have already calculated. So from this, R pi is 1.914 kilo ohm. Next is transconductance IC by BT. So BT is again 26 millivolt. IC you have already calculated. From this, transconductance 104.5. Now R naught is BA by I. See. So now BA is given in the question is I guess infinity. So if BA is in infinity, R naught is infinity means it will not connect it in the circuit. Okay. So that is on step 2, transistor parameters. Now the step 3 is main your AC analysis. Okay. Now this is your circuit. Okay. Now remember, whenever we do the AC analysis, at that time normally in mid frequency capacitor short circuit, but we are doing low frequency analysis, so capacitor will not short circuit. It will be connected as it is. But whatever the DC supply, that will connect it to ground. Okay. So that is removed. That's why in this circuit the BCC is not connected here. Okay. Now see, if you will convert the circuit in a mid frequency equivalent circuit. So remember how to draw the circuit. Just remember, this is your collector, this is your base, and this is your emitter. I have already explained you for simple BJT. This circuit is fixed. From collector to emitter, there is a current source, and from base to emitter, there is an input resistance. This will be your R pi, or this will be your GM into V pi. This is fixed. Okay. Now, after that, you have to connect the extra circuit. What is extra circuit at basis? There is BS, there is RS. Okay, there is CC1, there is CC1, and there is RB also. So that extra circuit you have to connect after that. Okay. Same here. Here it is RE, and here is CE, whatever. Okay. But remember, since we are doing not CC, it will be RE. Okay. So RC, sorry, this is a misprinting RC. So remember, if you are calculating low frequency, then remember first thing, all the voltage source will be short circuit. All the current source will be open circuit. And all other capacitors will be short circuit. These three fundamentals. Whatever the voltage source, this is the voltage source, that will be short circuit. Okay. Whatever current source here, that will be open circuit. And all the remaining capacitors will be disconnected. So in this question, I guess only one capacitance was given in the question. Only one capacitor, CC1. Okay. So only one capacitor, CC1 will be here. Okay. I guess again I am repeating this thing. This is your capacitor, this is your base, and this is your emitter. Okay. In normal mid frequency analysis, here there will be a current source GM into V pi. Okay. If you will do normal analysis, this is your RC. So here one RC will be connected. Okay. And this in normal analysis, this capacitor will be short circuit, and here voltage source VS will be there. This is your called mid-frequency equivalent circuit that I have already explained in the previous lecture with small analysis. Okay, but whenever do low frequency analysis, then what will happen in the low frequency analysis? This source will be short circuit because it's a voltage source. This is a current source, it will be open circuit. And since the low frequency analysis, capacitor will be connected here. So that is the difference between mid frequency and the low frequency. Okay. Now we have to calculate the frequency across CC1. So we want across this what is the equivalent resistance and what is the equivalent capacitance. Capacitance will be CC1 and what is the equivalent resistance. Okay. Now see. I'm redrawing it. Their resistance is like this. This is your RS. Here is CC1. Okay, RS. Here it is CC1. And next is RB, R by RE. Okay, this is your RB. This is your R by. And here and down this is RE. Okay, now we want to calculate the equivalent resistance. So first we will solve this part. Okay, now remember here the current is IB. But here current is very good, IE. But we want the same current because we'll apply the KVL in the whole equation. So current should be same. So if current is IB, so here we will not write IE, here we will write IB 1 plus beta because IE is 1 plus beta IB. Okay. So now I have already explained you the concept. What is the concept now? If we'll check the total resistance in this part, what will the total resistance in this part? Very good, R pi plus RE into 1 plus beta. RE into 1 plus beta, remember. Again remember here current is IB, here current is IE, but in terms of IB, the current is IB 1 plus beta. When you will check only IB, so what is the resistance here? R pi and here resistance RE 1 plus beta. The total resistance is R pi plus RE 1 plus beta. Okay. Now the circuit will be like here it was the same. Here it was CC1. Now here was RB. Now circuit will be like this, and this resistance is R pi plus 1 plus beta RB. Okay. Now these two resistors will be in parallel. That's why it is written RB parallel ZB. Means suppose I am giving this name ZB. So now equivalent resistance will be RB parallel ZB. Okay, RB parallel ZB. So what I will do, I am roughing this. And I will now write only one resistance, that is RB. Sorry. Now there will be one resistance, that is RB parallel ZB. Okay. Now across this capacitor, these two resistors will be in series. These two resistors will be in series. That's why total resistance is RS plus this resistance. Okay. That is we given ZI. Okay. So these two resistors will be in series multiplied by capacitance. So this is time constant. Now formula of frequency is 1 upon 2 pi R into C. So R equivalent is this one, RS plus ZI multiplied by C. So when you would put all the values, your low frequency will be 1.767 Hertz. Okay, pause the video and solve this calculation and check whether you are getting the correct answer. Okay, that was the next step. Now next, after this, we have to calculate the mid frequency because this analysis was for low frequency, but now for mid frequency, that I have already explained, there was CC1 here connected, but for mid frequency analysis, this capacitor is short circuit. This capacitor is short circuit. Okay, so now this is your collector, this is your base, this is your emitter. So this is small signal equivalent model. Actually, we have to do first mid frequency analysis, then it can be more clear to you. Okay. Now, either you can write GM into B pi, or you can write beta IV. Both are same because both are the formula of IV. You can write IC equals to GM into B, or you can write IC equals to beta IV. So it doesn't matter. Okay. So here it is written beta into IV because beta we are already having. We can easily calculate. Now mid band voltage gain means whatever the actual voltage or what is the actual input means the final output or the main input. The ratio of that we want to calculate. We want to calculate V naught by Vs. Okay. So see here, voltage gain. V naught is simply out. This is your output terminal. So what is output current? What is output resistance? Multiply both. That is output voltage. So output current is beta IB and output voltage, output resistance RC. So beta IB into RC is your output voltage. So the direction of current is towards down. That's why sign is minus. So output voltage V naught is beta IB into RC. Now, what is the input voltage? Voltage across this. This is not VS, VI. VI voltage across this means simple. The current multiply by equivalent resistance. So you can't take R pi. So total resistance here. Or just before a minute, I have explained it. Total resistance will be R pi plus 1 plus beta into R. Because we are taking the input current IV. Now this is, here is also current IV flowing. Now here is also current IV flowing. Okay. We have put I equals 1 plus beta IV. Now in terms of IV, so IV is separate. So RE will be RE 1 plus beta. So total resistance will be R pi plus RE 1 plus beta. That is your ZB. Already we have calculated. ZB RE 1 plus beta plus R pi. Okay. So put the value of IV will be calculated. So this is V naught by V in, not Vs. This is V naught by V in. But we want to calculate V naught by Vs. So what we can write? We can write it like V naught upon V in. We want V naught upon Vs. So what we can write? V naught upon V in multiply by V in by Vs. So what will happen? This V in will calculate. So V or not V in, we have already calculated. Now we want to calculate V in by Vs. Okay. So now what is V in by Vs? V in by Vs is now voltage divided. V in is Vi is this and Vs is this. So voltage equivalent circuit will be, suppose here this is Zi and this is Z in. So Zi upon Zi plus Zn into given voltage. Okay. What is Zin? We have already calculated here. Zi is your again listen. We want to calculate voltage across this. So across this resistance is total. Panel RB means in short this is your RS. Okay. And this is your RB. And this is your R pi RE1 plus beta. R pi RE1 plus beta. Okay. So what will happen? Now total voltage across this is, again I am writing, this is your RS, this is your RB, and this is your R pi plus 1 plus beta. 1 plus beta RA. R pi plus 1 plus beta RA. That we have given name ZB. Okay. And this is your RB. So ZB parallel RB is your ZI. So you can write this is your RS or this is your ZI. Okay. Now we want to calculate voltage across ZI. Voltage across ZI will be by voltage by rule. Zi upon Zi plus RS. RS they have given Zin into given voltage Vs. Okay. So just multiply of last gain with this, you will have the actual voltage gain. Okay. Okay, is it clear? So now voltage gain is minus 8.6. Means what you have to do? Simply we have to calculate V naught by VI and VI by VS and just multiply by both. So V naught by VI here, beta IB RC upon IB ZB, this is a V naught upon VI, and VI upon VS is here. ZI means RB parallel R5 plus 1 plus beta IB, okay, upon RS plus this resistance multiplied by VS. Okay, so that will be your output voltage. And then divide by VS, it is voltage minus 8.6. Okay, this is the end of numerical 1. Now numerical 2, the same type of numerical, but it is not mentioned you have to calculate the low frequency or high frequency. It is mentioned you have to calculate 3 dB frequency. Now what do you mean by 3 dB frequency? This is your frequency response. Now this is also 3 dB frequency, this is also 3 dB frequency. When the gain falls, that is your 3 dB frequency. Well, it can be low frequency and it can be high frequency. For low frequency, your capacitance, bypass capacitance comes in picture. For high frequency, your internal capacitance or junction capacitance will be in picture. So this is the circuit given. Now remember, in this circuit, no transistors junction capacitance are given. Means between B, C, R, or we can say C pi, C mu. So no transistor junction capacitance mentioned. So means we have to do only low frequency, so no high frequency. And since CC1 tends to infinity, means it will behave like a short circuit. So you don't need to take this capacitance picture. So just you have to calculate the frequency across the capacitance CC2. Okay. So now step 1, you know, always there is the first step 1 is DC analysis, because from DC analysis we need current I, and current I is useful for finding the transistor parameters. Okay, so DC equivalent circuit, now it is clear to you how to calculate DC equivalent circuit. DC equivalent circuit is voltage VBC. This is not the voltage divider circuit, this is normal circuit. So for normal circuit, when you will do DC analysis, so remember for doing DC analysis, their capacity will be open circuit. So for DC analysis, what will happen? This will be open circuit because AC will be disconnected. Okay, now circuit will be RB and the remaining circuit will be same. Okay, same here also it will be open circuit, this part will be disconnected. Only this circuit will be here. RB, RE, and this minus. This is voltage. Okay. Now we have to apply the KVL. Okay. Or if you want, you don't want to apply the KVL, just I have already explained you the simple trick. Just take the difference between voltages. Since difference between voltage means one voltage VB that is given 0.7. Okay, and one voltage is 10. Okay. So see where is the sign? This 10 voltage sign is minus to plus. So we'll take them like this: 10 minus 0.6. Okay, and the rest is difference voltage divided by total resistance. So resistance RB plus RE, but we will not take RE. We'll take RE 1 plus beta. Why 1 plus beta? I will explain you that here actually current is IE, but I equals to 1 plus beta into IV. And since we are taking the equation terms of IV, so total resistance will be RB plus 1 plus beta RE. RB plus 1 plus beta RE. The difference in voltage is VEE minus VBE, and difference divided by total resistance RB plus 1 plus beta R. That is a short trick what I am explaining you. Otherwise, just take the KVL equation. What is the KVL equation? IB RB minus VB minus IERE minus VE equals to 0. And then you have to put I equals to 1 plus beta I. Because we want to calculate IB. So whole equation should be in terms of IB. Once you have the value of IB, then put IT equals to beta IB, then you will have the value of IB. Step number 2 is the calculation of transistor parameters. So you know R by input resistance, VT upon IBQ, VT thermal voltage, GM is ICQ upon VT, and R not output resistance. Now In the previous question, it was not connected because BA was given infinity. But in this numerical, BA is given 120. So here output resistance will be connected here. So expression of output resistance BA upon ICQ. That is BA is given, ICQ we have already calculated. So this is your answer. Now, calculation CDV frequency, we are simply calculating the lower frequency. So see in the numerical, CC1 is terms to infinity, means it is already short circuit. So it is not in picture. CC2 is main parameter. Okay. So what you do, what you will do, just draw the mid-frequency equivalent circuit. This is mid-frequency equivalent circuit. In mid-frequency, then in mid-frequency equivalent circuit, that's what you will do. Just connect the capacitor. First, draw the circuit without the capacitor. That will be easy to. You know, this is your collector, this is your base, this is your emitter. And this part is fixed for the transistor. You have to connect the current source. Either you can write it is GMB pi or you write beta into IV. And here alpha, this part is fixed. Now, since in the numerical VA is given, you have to connect output resistance. After that, check what is at input side. So input at base, there are two resistors, RS and RB. And here, one voltage source will be there. Okay, one voltage source will be there. Then at emitter, R0 and RE is there. Okay, and for collector, there is nothing. After that, once you draw the circuit, then you know voltage source are short circuit and current source will be open circuit. It is not shown here, but it will be open circuit. All the current source will be open circuit. Okay. Now we have to do analysis across this capacitance CCC. Okay, and the one thing is that here output is not taken at the collector. Output is taken at the emitter. That is the main point. Okay, output is not taken at collector. Output is taken at the emitter. That's why the R0 resistance connected here at emitter because it's output up. Now it's your time how to calculate the equivalent resistance across this capacitor. Means this the circuit should be like this. This is your capacitor CC2. Here RL is fixed. Here RL is fixed. But what will the resistance at the left side? Just have a thought. Just think about it. How to solve this circuit. Okay. Here the analysis is done by step by step. First, start from the left side. Okay. This is also open circuit, so this part is not of our interest. Remove this part. This part is not of interest. Just our interest is in this part. Okay. Now we have to find the equivalent resistance. So first of all, these two resistors are parallel. Okay. So RS parallel ZB. Then this will be removed here. This one resistance will be RS parallel RB. Then R pi in series. So that will be RS parallel RB plus R pi. That is on above side. Is suppose this is your Z1. Z1 is RS parallel RB. Then for Z2, R pi will be added. RS parallel RB plus R pi. Okay. Now this is your emitter. I have to take one space. See, suppose this is your RS parallel R pi. Okay, sorry, RS parallel RB. Okay. Now here R pi here, right? Now R pi here, then here R0 is there, and here RE is there. Okay. Now these R0 and RE will be in parallel, right? And these two resistors will be in series. So now at above side it will be RS parallel RB plus R pi. Plus R pi. This is above the emitter. We have given this name as a Z1. Okay, this is your base. And at down, what is the resistance? R not parallel RE. R not parallel RE. Okay, R not parallel RE. This is your resistance. Now, since I have already explained you just before, okay, this is your Z1. Okay, this is your base, and here the resistance is R not parallel RE. Okay, R not parallel RE. Now, what is the main terminal? Ammeter. So current here will be ammeter current, but current here will be base current. Now, what is the main terminal is ammeter. So base current in terms of ammeter current will be IE upon 1 plus beta. IE upon 1 plus beta. Again, listen carefully what I want to explain. Here current is IB, here current is IE, but we have to take the same current. So in the previous case, we have given written here I equals to 1 plus beta IB because the main terminal was base, because the CC1 was here. But in this case, your main terminal is CC2, main terminal is ammeter. So now convert IB into in terms of ammeter. So IB in terms of ammeter, I upon 1 plus beta. So now I is, if I is separate, then Z1 is Z1 upon 1 plus beta. So now circuit will be like this. The upper part, this will be Z1 upon 1 plus beta. And the lower side, it will be R naught parallel RE. And this is here, it is node. Okay. So now remember, here is also current IE. Here is also current IE. Sorry. Okay. My mouse is stopped. 1 second. So what I want to say, this is Z1, this is suppose Z2, whatever. This is Z1 upon 1 plus beta, because here the current is now IE, not IB. Okay, and this is your R not parallel, whatever here RE. Okay, so now here is also current IE, and at the top is also current IE. So just what you have to do in any analysis, remember which is the main terminal. If main terminal is base, then you have to convert IE in terms of IB. But if main terminal is ammeter, then you have to convert IB in terms of IE. Okay. Now, since there is a node here, so these two resistors will be in parallel. So total resistance will be Z1 upon 1 plus beta, then parallel R not parallel RE. Okay. So now, so what was this? This is your CC2. This was RL was fixed. This was CC2. This is RL fixed, and this was your Z1 upon 1 plus beta parallel R naught parallel RE. Okay, this is your total resistance. Now across this capacitance, these two resistors will add up. So suppose it is your RE dash, then total resistance will be RE dash plus RL. So total resistance will be RE dash plus RL. Okay. Now, you know, frequency is 1 upon 2 pi into R into C. C is given 0.01 and your R is 10. Let's put all the values, you will have the value 15.91 Hz. Okay. So, this is your lower cutoff frequency. This was end of numerical 2. Now, numerical 3, again the same type of numerical. Determine low frequency response. And the value of R pi and beta is given. Now in this question, all the capacitors are given, CC1, CC2, CE. Now you have to do analysis by taking one capacitor at a time. First you have to do analysis with respect to CC1, then you have to do analysis with respect to CC2, then you have to do analysis with respect to CE. So this is directly low frequency equivalent circuit. You know, for any low frequency analysis, your voltage will be short circuit, your current source will be open circuit. Now 3 capacitors are given, but at a time one will be taken. So if we take CC1, then CE and CC2 will be short circuit. So first we are doing CC1. If you are doing CC1, this will be short circuit, so RE will not be involved. Okay, and CC2 will also be not in role. So what is the circuit remaining? Only this one, RS, CC1, RB. Okay, now you know very well across this capacitor, both resistors will be in series. Okay, now first of all, remember these two resistors will be in parallel, RB parallel R pi. That's why here RB parallel R pi. Now these two will be add up, so it will be RS plus RB parallel R pi. Now frequency is, it is not frequency, here it is tau. Tau is equals to R into C, total resistance and total capacity. Then frequency is 1 upon 2 pi into tau, or we can say 1 upon 2 pi into R into C. So 10.60, please pause the video and verify your results. Okay, this is with respect to C1. Now with respect to CE, for CE, this capacitor which was placed here after RS. So after RS, this capacitor short circuit here, and this capacitor short circuit. So it is open here, so this part is not in there. Okay, there is no issue. Now, again the same concept which I have already explained just before a minute. These just do this. RS parallel RV. Whatever resistance here plus HI, or you can write R pi. RS parallel RV plus R pi. That is one resistance here. I'm giving its name Z, and the other resistance RE here. Since the main terminal is ammeter, so this will be Z upon 1 plus beta. Z means RS parallel RB plus R pi upon 1 plus beta. And these two will be in parallel. See here. RS parallel RB, then HIE plus upon 1 plus HFE is your beta. If you are writing HFE or beta, it is same. Okay. So RS parallel RB plus HIE upon 1 plus beta, then I will explain it at this node, both are in parallel. Okay, both are in parallel. Means simply it is Z upon 1 plus beta parallel combination with RE. Okay, what is Z? Z is your RS parallel RB plus R pi, then divide by 1 plus beta. This is your, okay. So if the last question is clear, then it will be clear. And if you are solving with me parallel, then it will be more clear, because these are some difficult complex type issue problems. Okay. So again listen, RS plus RS parallel RB plus HIE. Since we are taking at ammeter, so it will be divided by 1 plus beta, because current IV is I upon 1 plus beta. And parallel RE, so this is your total R. Okay, and there is nothing after this. If you suppose after is RL, then both resistors will be parallel. But in this question, there is nothing after this. So this is total R, and your C is given in the question, that is 22 microfarad. So low frequency 1 upon 2 pi into R into C. Put the values, answer is 475.6. Now C2 is now this is the turn of this capacitor CC. At CC2, this capacitor short circuit, this capacitor short circuit. Since here it is open circuit, it is difficult to calculate. So we'll not calculate this part. FL2 can't be calculated because path to find the series with CC2 is open circuit. We can't find, okay? Because it is not connected here, it is open circuit, so we cannot calculate. So this was the end of numerical third. So next numerical 4, calculate Q point and find capacity. Now frequency is given, you have to find out the capacity. This upward method is same. But in the last step, when you will put the formula F equals to 1 upon 2 pi R into C. So in the previous question, you have to calculate F. Now in this question, you have to calculate C. So this C will be here, F will be here. Only this is the difference. Otherwise, all the steps are the same. Okay. Now see, this is circuit again CC1, CC2, CE, all the parameters are given. The first step is same. We have to do DC analysis, draw the voltage divider equivalent circuit, or we can have an equivalent circuit. Then I have already explained you how to calculate IB. Difference in voltage is 5 minus VB. V minus VB divided by total resistance RB plus 1 plus beta RE. Because here current is I, but we are taking in terms of IB. So resistance is RB. First, you know how to calculate R is R1 parallel R2 and voltage equal circuit BC R2 open R1 plus R2. Just put this. Okay. So this voltage equivalent circuit is R2 upon 1 plus R1 plus R2 into VCC. When you will solve this, you will have value 5. Okay. And this is your R1 parallel R2. When you will put the value of R1 R2, then you will have 3.75K. Okay. After this, IB is B minus BB upon RB plus 1 plus beta RE. So from this equation, we will have IB and IC equals to beta into IB. Since we want to calculate the Q point, I will explain you if Q point is not asking in the question means you have to calculate IC. If Q point they want, you have to calculate the BC. And for BC, just apply KVL in the right side equation. Okay. And otherwise, you know what is the trick? Difference in voltage BCC minus BC upon resistance RC plus IRE. I means 1 plus beta RE. So by same method, BCC minus ICRC minus IR, or you can put 1 plus beta R. Okay. So from this method, we have calculated DC. That is a step 1. DC. Now step 2, low frequency LC analysis. Now the same concept. If you want to calculate CC1, then this will be short circuit and this will be short circuit. So there is no part role since it is short. Sorry, capacitor should be short circuit. I have by mistake done. This capacitor is short circuit, then there is no effect of R. Okay, and this, since it is open circuit, there is no effect of here. So for CC1, the circuit is simply this is your CC1, this is your RB, and this is your R5. Simple. So what is the total resistance is RB parallel R5. Simple. Total resistance RB parallel R5, and the capacitance we have to calculate. So now C is 1 upon 2 pi F into R. So F is given 20 Hertz and R is RB parallel R5. So in this way you have calculated CC1. Now for CC2, there is no issue. Simple RC is given, RL is given. Here, see here for CC2, what is the circuit? Only this part is there, RC and RL. So both resistance will be add up RC plus RL, and the frequency is given. So again the same formula. CC equals to 1 upon 2 pi F into R. F is 50 and R is 12. F is not 50, it is 20. There is some mistake here. Just put 20. The question, what is the frequency given? 20. That is a printing mistake. You have to put the value of 20 here. Okay, it is 20. So solve this, you will have CC2. So for CC3, again the same concept. Sorry, for CE, there is nothing here, so we will not calculate. So thank you so much. Keep learning, keep sharing. If I have any doubt, please you can ask in chat box. God bless.